Okay, so buenas tardes a todos. My name is Cindy Chesney, and I'm with Maestro Digital Mine, a Canadian company. We manufacture air quality monitoring stations. Do you speak Ethernet? Real-time data means real-time at the working face. Thank you. Sure. So what does this mean to you? It means more time at the working face, allowing miners to get back in line and re-enter safely after blast gases. Greenhouse gas reduction to support initiatives by reducing ventilation by 20 to 50%. Energy savings by directing the airflow, ventilation. Oh, sorry, one more. By directing the airflow where it is required and reducing the air where there is no workers or where there's no equipment running. Monitoring for regulation using real-time data, accurate data that can be maintained and used when required, and OPEX reductions by eliminating legacy equipment and providing real-time diagnostics with maintenance decisions for maximum uptime. The equipment we use, we can monitor the airflow and monitor auxiliary fans, air quality monitoring stations, software, which is your maintenance software, which will take all the data from the air quality monitoring stations and manage it for you, as well as provide a maintenance schedule on all the equipment. Airflow monitoring, last mile, 1 gigabyte communication backbone. It's powered through a single coaxial cable, providing data and power to the network. Has 4 PoE plus ports, so any third-party Ethernet application can be connected to this system, and data and power is provided through a Plexus node. LED displays, they're fail-safe display, 8 lines of data, 2 rotating pages. You can post the data from the air quality monitoring stations. It's a tricolored screen, so it can accurately measure and display if there's a hazard within the mine and the gas levels are high. And regulators and actuators, which are Ethernet based. This is a scenario on what a complete system would look like. On the far right is going to be your air rays, and you'll have a regulator. It's all being powered by the Plexus PowerNet system. So the Plexus is powering the module drive, which will control the regulator, which will open and close the louvers. Air quality monitoring station is monitoring the gases within the environment. Airflow monitors the airflow within the drift. And the super bright marquee, which is being utilized to post all the data from the air quality monitoring stations. And again, this is all being powered by the Plexus power node. So each item does not require individual power. We make the complex simple. We're in 38 countries, 150 different mines. And I'm just going to briefly touch on a few case studies of mines that are using our equipment and show you the different applications that are available. A mine in Peru had fans that they wanted to control and monitor and integrate into one system. It's a Vulcan mine. They mine zinc, lead, copper, and silver. The challenge for them was to integrate a SCADA system with the 3 fans. So they had 3 fans that were not being monitored. They weren't designed to be monitored, but they needed to collect data from these fans and put it into their SCADA package. The solution We incorporated a vigilante with gas monitoring for them. We integrated it into their system. The sensors are calibrated on surface, so they did not have to turn the vigilante off. Sensors are hot swapped, and we combined all of the fans together. This is the data that is being pulled from our equipment and from their sand. So this is their SCADA package. You can see that we're monitoring different aspects of the fans themselves, as well as we're monitoring the gases within the environment. The results, all 3 fans were integrated into their SCADA package. They're ready for future ventilation on demand. The gas sensors there are hot swapped, so they don't have to turn the vigilante down. Nevada Gold Mines, they were wanting to have sensor calibration. They needed a better way to calibrate. They are mining gold, metals, and precious metals. Their challenge was environmental conditions with toxic gases and from the blasting operations, vehicles. What they needed to do was find a way to calibrate the gas sensors without having problems. Currently, they were using air quality monitoring stations where they had to calibrate gas sensors at the stations themselves. The solution had to be economical, and it had to be easy for them to calibrate. The solution was to install vigilantes to monitor the gases. They measured airflow. They also installed a super bright marquee where they're showing the data from the marquee itself. They installed tri-light, which had set points set. So when the gases hit certain levels, it would change and alarm the miners that the gases were at a higher level. So as the gases rose, the lights would turn to amber, and then if they were extreme, they would turn to red. All of this was integrated into their SCADA system. The results, standardizing of mine monitoring equipment and easy integration for new devices, and they were able to optimize their blast clearance time by using real-time data. The vigilante is very easy. It's the setup, the monitoring, the digital communications always work, easy to calibrate, install, and maintain. And that's just a testimonial from one of the gentlemen at the mine. The next mine is a Vale mine. They were going to improve ventilation monitoring and control to reduce energy consumption and improve worker safety. They mine copper and nickel. The challenge to increase automation capacity, reduce the time to advance the automation infrastructure, reduce costs by removing expensive and unnecessary hardware and software, and remove and bypass PLCs where required, and improve monitoring and control capabilities of their existing systems. The solution, the vigilante was installed. And with the vigilante, they did use a Wi-Fi access point, which is connected direct to the PoE port of the vigilante. They have Maestro Flex regulators and actuators, and they do airflow monitoring. Connecting the Wi-Fi access point to the vigilante direct eliminates the requirement for a power supply to power the access point. The results. Standard processes with Maestro Vigilante air quality stations. Ventilation controls provided a 49% reduction in energy and a 10% productivity improvement. By connecting the access point direct to the vigilante, they eliminated the power supply and they reduced the total cost of installation, complexity, and unnecessary labor. The Matroflex regulator and regulators are installed on every level of this mine. They originally were set up with actuators that were analog. they've now switched over to the Ethernet-based actuator, which reduces costs and increases production. Significant reductions in installation cost, equipment lead times, and monitoring and controlled hardware completely without compromising the software that was already inside. Advanced diagnostic features are enabled from surface and to help keep uptime of the equipment. So they can diagnose any problems from surface, and then they can go down, and they know what the problems are. Vigilante is easy. It's a single box. It doesn't require any maintenance, any programming to it. Digital transformation supported for safer, automated underground ventilation methods. So when you take all of these solutions that are incorporated and make it into one big solution, you're going to reduce the energy costs and increase productivity. We make the complex simple. Everything we do is Ethernet based, so you're removing a lot of the programming and engineering time. Any questions? Preguntas?
Hola,
Hola.
¿Te puedo preguntar en español? ¿En English? Sí. Oh.
It's fine, she'll translate for me.
Ok. ¿Cuánto han estimado ustedes el ahorro real? No el potencial, sino que el ahorro real al instalar un sistema integrado de ventilación bajo demanda.
The real cost or the cost savings? The cost savings. Yeah. So everything that Maestro Digital Mine does must return 50% of their actual costs. We develop and design that they actually do that. So we have mines that have given us all of their stats and have proved that we have been able to save them that amount of money. So everything is designed with that in place. Okay, so it's a combination, of course, of energy costs, installation costs, maintenance costs, extending the equipment into different levels. So it all combines into that type of a savings for the mines. Like when you're running fiber, of course, fiber is expensive to run. If you have to have special people to run it, a coaxial cable is very cheap. It's easy to advance, and any miner can do it. So you're saving the costs from that perspective.
Eso es pensando en una mina que tiene instalado un sistema de comunicaciones. 50%, ¿te entendí? Que el 50% de ahorro que hablaste está relacionado a una mina que ya cuenta con un sistema de comunicaciones funcionando.
If they're already using a communication system and they want to put in ventilation controls, is that what the question? How much will they save?
Sí.
Yeah, I mean.
Sí, sí.
Yeah, so the ventilation is going to save on the energy costs, and it's also going to increase the production, and that being the time that they enter into the mines after the blast clearance. So we've had mines that have told us, using real-time data, they've been able to increase production by 2 haul trucks every blast. So every blast routine, they can increase production by 2 haul trucks. So if the haul trucks are worth $50,000 each, they're increasing production by $100,000 each blast. Yeah. Does that make sense?
Mira, ¿sí se oye? Sí. Una cosa es, normalmente ellos instalan, o sea, en general instalan estos sistemas una vez que ya tienen todas las líneas de comunicación. O sea, generalmente. Es muy raro que instalen un sistema de maestro o curso de la competencia sin tener un sistema de comunicación. Es muy raro, ¿no? Y luego, una vez que ya tienen el sistema operando con maestro, el ahorro sobre todo viene también cuando lo tienen de manera integral, por ejemplo, con la ventilación secundaria, no solo con la principal. Porque normalmente, si lo tienen solo asociado a la principal, como la secundaria no suelen tener buenas instalaciones de promedio, es muy raro que regulen, que hagan un ajuste en la secundaria, ¿no? O lo tienen apagado o lo tienen encendido, no tienen ajuste. Entonces, al no haber ajustes en la ventilación secundaria, es muy raro que tengan que ajustar en la principal. Eso es lo que suele ocurrir normalmente, ¿no? Entonces, el ahorro viene sobre todo, al menos en las minas que yo conozco de aquí, cuando son capaces de integrarlo todo de conjunto. Y si no, no hay tanto ahorro. Entonces, es cuando se hace de manera integral, ya partiendo de un sistema de comunicación, ¿no? Y luego, otra cosa que ellos, bueno, cuando empezaron el negocio aquí en México, fue con los tiempos de liberación de los gases de la voladura. Entonces, ahí sí tenían un coste muy alto de espera. Entonces, sí los instalaban mucho próximos a las voladuras en las áreas de explotación minera, ¿no? Y entonces, de esa manera, tenían monitoreado cuándo podían entrar o no y ahorraban mucho tiempo. Así, por ejemplo, la mina de Palmarejo, que no por aquí, los instalaron precisamente para eso. En todas las zonas de producción, ahí los tenían instalados, tenían unos semáforos, dicen, venga, entra ya. Y con eso ahorraban mucho tiempo, o sea, en costes no solo en energía, sino en tiempos de operación, ¿no? Eso es un poco como lo que... Pero siempre partiendo de que tenían ya un sistema de telecomunicación, ¿no?
Ahí, ¿me escuchan? Sí. I can do the question in English, no problem. Maestro have been around for a while, so I know that in terms of airflow sensors, so is there any difference that you have developed in the past 10 years, for saying, like if you want to read the air velocity in a fan instead of in a drift, have you made any changes since then?
Well, Maestro continually develops our equipment, so we have an engineering team that works with us. I mean, they're part of Maestro's group. So we're continually upgrading all of our equipment. Maestro is a relatively new company. This is our 11th year. So we're a very new company in regards to, longevity. We have increased the number of gas sensors. We're just releasing a Vigilante 2. It has other options that have become available to it through the use of the Vigilante. It will take up to 8 gas sensors as well instead of the 6. And there's a number of other options that are coming with that one. As far as the actuators, we manufacture our own actuator now, but we have a company that does it for us. So it's Ethernet based, it's electrical, and it replaces the older analog actuators. So that has definitely decreased costs and increased just the availability of them because they're Ethernet based. So there's only 2 wires that go into that actuator. One's power, one's the Ethernet cord. So your savings in time, the programming side of it and the connection side of it. So we're continually upgrading to the Ethernet base.
No,
digital.
In terms of communication, I have no issues with that. It's just on site, you can see it's very hard or difficult to read the air velocity and the fan discharge compared to an air drift. So I know that there are many brands for airflow sensors outside, and mostly all of them, they have the same issues. So that's my question is focused on, have you guys improved like the accuracy of the reading?
The accuracy of the airflow reading. Yeah, we have some smoothing features that we use as well. So when you take down an aeronometer and you can get an actual manual reading, right? And then we can compare that to the airflow sensors. So we have smoothing features that can help you to get to that, exact monitoring, which does help. So that the readings are definitely more accurate than what they used to be. Does that answer it? Okay. Why not? Yes.
Cindy,
Yes.
voy a hablar en castellano que es más confortable para mí. en general, todas las cosas que le ponemos a los ventiladores, como que complican más los sistemas. Nosotros estamos viendo harto de automatización y dentro de eso yo pienso que lo más importante es cómo calibrar los sistemas y qué tipo de mantención tienen tus sistemas de medición de gases. ¿Nos podría hablar un poquito de ello?
So the maintenance of the calibration of the gas sensors themselves? Yes, so the calibration, we recommend that you start at every 3 months, but every mine environment is going to be different. So some mines may need to calibrate monthly. Some mines may only need to calibrate the gas sensors every 6 months. So it really depends, but we do suggest you start at a 3-month calibration period and then do the testing, do a bump test on the gas sensors to see if it's still in calibration. And that way you can gauge the time frame to do the calibrations yourself. We have in our software, it does monitor that for you, as well as when you calibrate, you put in the dates of calibration, it will remind you when the calibrations of those gas sensors are required. So once you have an established time frame to do it, the software will help you to ensure that that's put into a regular maintenance schedule.
It's easy.
Easy, very easy.
And what about the maintenance?
The maintenance of the systems themselves, the gas units do not require much maintenance at all. They're IP65, so they're sealed units. The only time you're going to have to do any maintenance is if some type of a connection breaks, the cable going into it breaks, but the units themselves require very low maintenance. There's nothing really to do to them. Okay?
Perfect.
Thank you. ¿No más? No, perfecto. Muchas gracias.